NASA reports that the Voyager 1 and 2 has made fresh findings concerning the boundary between our solar system and interstellar space. Interstellar, which implies between stars. We are about to find out what NASA chief just leaked concerning Voyager's shocking discovery in space. According to the experts working on the project, the scientific equipment aboard the Voyagers detected surprising changes in the density of plasma. Notably, the plasma instrument on board Voyager 1 was destroyed before it completed the crossing, which meant that it was unable to determine with absolute certainty when plasma from the solar wind was replaced by the colder material that exists in interstellar space. But the same device that was on board Voyager 2 is still running, and it gave academics their first opportunity to analyze plasma in interstellar space. Plasma is basically a collection of charged particles that may be found in the solar system, which could validate the findings that NASA chief leaked information concerning Voyager's shocking discovery in space. Voyager 1 and Voyager 2 both appear to be in a transitional region just outside the heliosphere, according to NASA's interpretation of the recent study findings, which confirms this interpretation. The heliosphere may be thought of as a bubble that surrounds and defends the solar system. The solar wind, which is composed of charged particles, is the source of this phenomenon. The heliopause is the boundary between the solar system and the space between the stars. It is also the point at which solar wind ceases and space between the stars starts. The group claimed that evidence from Voyager 2 reveals that it looks that the heliopause is substantially narrower than was predicted. Edward Stone is a project leader for the Voyager mission, as well as a physicist at the California Institute of Technology. Stone was quoted as saying to the reporters that the discoveries mark a very exciting time for us. In a statement, he stated that the Voyager 2 mission was revealing insights about the ways in which the sun interacts with the materials that fill the majority of the space in between the stars in the Milky Way galaxy. In addition, as Voyager 1 passed through the region, the barrier looked to have been pierced by the magnetic field of interstellar space as well as cosmic rays, which caused it to appear to be somewhat jumbled. On the other hand, Voyager 2 discovered a heliopause that was more clearly stratified and where there appeared to be less invasion. After passing through the barrier, the Voyager 2 spacecraft discovered evidence that some charged particles were making their way into the interstellar medium. According to Stamatios Krimidis, who was the chief scientist of the low-energy charged particle experiment on Voyager, the crossing by Voyager 2 was very leaky. To put it another way, matter from the solar bubble was making its way upstream into the galaxy at distances of up to 1 billion miles. That was a significant departure from what had occurred with Voyager 1. What may have brought about these differences? This is still not apparent to me. There is a hypothesis that solar activity might affect the basic geometry of the solar system itself, as well as some of the distinctions that exist between its components. Regrettably, there are no additional spacecraft now on their way back to the heliopause to address the questions that have not yet been answered. NASA's New Horizons, the spacecraft that is currently closest to Earth, did successfully explore the most distant world in the beginning of 2019, but it is not anticipated that it will have the fuel to travel all the way to the frontier of the solar system. Even though the two Voyager probes have been working their asses hard for the past 42 years, the plutonium-238 that supplies them with energy is progressively losing its heat. This is a very unfortunate development. Astronomers estimate that the probes will be put into permanent hibernation in around 5 years' time. Up to that time, they ought to be able to carry out more measurements in the region between the stars. According to the findings of researchers, the spacecraft Voyager 2 was able to establish the presence of a magnetic barrier at the heliosphere's periphery, which was something that Voyager 1 had seen and that had been anticipated by theory. Without this new data from Voyager 2, we wouldn't know if what we were seeing with Voyager 1 was characteristic of the entire heliosphere, or if it was specific just to the location and time when it crossed, Stone claimed. One of the papers was led by the research that was conducted by Leonard Berlanga, who is a scientist at the Goddard Space Flight Center of NASA. He acknowledged to the French news agency AFP that there were a few unexpected developments. Contrary to all expectations and predictions, the magnetic field direction did not change when Voyager 2 crossed the heliopause, he claimed. When Voyager 2 passed through the heliopause. In addition to this, the spacecraft gathered data on cosmic rays, which are high-energy particles that may arrive at Earth from any place beyond its atmosphere. According to the collected data, the intensity of the rays increased as the Voyager explorers got closer and closer to the heliopause. Recently, the crew of the expedition experienced one significant setback when the spacecraft started sending home jumbled information regarding its location. Operations were resumed once the engineers determined the reason of the problem, which was that the spacecraft was making use of a flawed piece of computer gear when it should not have been. However, it is reasonable to anticipate that accidents of this nature will occur with an aged spacecraft. The crew is also actively controlling the power supply on board each spacecraft, which is decreasing at a faster rate each year due to the fact that the radioactive generators aboard the probes are becoming less effective. This year, mission workers shut off heaters that were keeping a number of scientific equipment on board warm in the harsh, cold environment of space. Much to everyone's astonishment, those instruments are still performing perfectly fine despite the fact that the heaters were turned off. Even though the cameras have been shut off for decades, the other sensors on the spacecraft are still gathering data on the plasma and magnetic fields emanating from the sun, even though they are located a significant distance from the star itself. Because particles of the solar wind, which is the steady stream of charged particles streaming from the sun, take time to travel such a long way, astronomers are able to understand how changes from the sun spread across our cosmic neighborhood by making use of observations made from a great distance. Even the outskirts of the solar system have been chock full of unexpected phenomena. In spite of the fact that the Voyagers have met significantly thicker plasma after passing through the heliopause, it would make sense for the plasma that originates from the sun to become less concentrated and more dispersed as one moves out from the core of the solar system. Astronomers have not yet figured out an answer to that one. The organization has stated that professionals from Voyager will continue their investigation into the problem and make an effort to either solve it or adapt to it. This is a time-consuming operation, since it now takes a signal sent from Earth 20 hours and 33 minutes to reach Voyager 1. Getting the answer from the spacecraft also involves the same amount of delay. The problem is in the Attitude Articulation and Control System, often known as AACS for short. This system ensures that the spacecraft and its antenna remain in the correct orientation at all times. In addition, the AACS appears to be operating correctly, given that the spacecraft is successfully receiving orders, carrying out those actions, and transmitting scientific data to Earth with the same level of signal strength as before. In spite of this, the AACS is transmitting useless telemetry data to the controllers of the spaceship. In its statement, NASA did not disclose when the problem first started or how long it has been going on for.